Let me just indicate how just the exponential notation enables you to do things in calculus, formulas that are impossible to remember from calculus. It makes them very easy to derive. A typical example of that is, suppose you want to, for example, integrate e to the negative x cosine x. Well, number one, you spend a few minutes running to a calculus textbook and trying to find out the answer because you know you're not going to remember how to do it. Or you run to a computer and type in MATLAB and something, or you fish out your little pocket calculator, which will give you a formula, and so on. So you have aids for doing that, but the way to do it, if you're on a desert island, and the way I always do it, because I never have any of these little aids around I trust her, and I cannot trust my memory. Probably a certain number of you remember how you did it in high school, or how you did it in 1801, if you took it here. You have to use integration by parts, but it's one of the tricky things that's not required on an exam, because you have to use integration by parts twice in the same direction, and then suddenly, by comparing the end product with the initial product and writing an equation, somehow the value falls out. Well, that's tricky. And it's not the sort of thing you can waste time stuffing into your head unless you're going to be in the integration bee during IAP or something like that. Instead, use complex numbers as the way to do this. How do I think of this? Cosine x. What I do is I think of that e to the negative x cosine x is the real part. The real part of what? Well, cosine x is the real part of e to the ix. So this is real. This is real too, but I'm thinking of it as the real part of e to the ix. Now, if I multiply these two together, this is going to turn out to be, therefore, the real part of e to the minus x. I'll write it out very pompously, and then I'll fix it. I would never write this, but you are you. Okay? It's e to the minus x times when I write cosine x plus I sine x, the real part of that is cosine x. So it's the real part of, write it this way, for real part of e to the, factor out the x, and what's up there is negative 1 plus I times x. Okay? And now, so the idea is the same thing is going to be true for the integral. This is going to be the real part of that, the integral of e to the minus 1 plus I times x dx. In other words, what you do is, this procedure is called complexifying the integral. Instead of looking at the original real problem, I'm going to turn it into a complex problem by turning this thing into a complex exponential. This is the real part of that complex exponential. Now, what's the advantage of doing that? Simple. It's because nothing is easier to integrate than an exponential. And though you may have some doubts as to whether the familiar laws work also with complex exponentials, I assure you they all do. It would be lovely to sit and prove them. On the other hand, I think after a while you'd find it rather dull. So I'm going to do the fun things and assume that they're true because they are. So what's the integral of e to the minus 1 plus I x dx? Well, if there is justice in heaven, it must be e to the minus 1 plus I times x divided by minus 1 plus I. Now, in some sense, that's the answer. It's not, does in fact give that. That's correct. I want the real part of this. I want the real part because that's the way the original problem was stated. I want the real part only. So I want the real part of this. Now, this is where what separates the girls from the women. This is why you have to know how to divide complex numbers. So watch how I find the real part. I write I write it this way, 1 over 1. I would skip, normally when I do the calculation for myself, I would skip a couple of these steps, but this time I'll write everything out. You're going to have to do this a lot in this course, by the way, both over the course of the next few weeks and especially toward the end of the term when we get into complex systems which involve complex numbers. There's a lot of this. So now is the time to learn to do it and to feel skillful at it. So it's this times e to the negative x times e to the ix, which is cosine x plus I sine x. Now, I'm not ready yet to do the calculation to find the real part because I don't like the way this looks. I want to go back to the thing I did right at the very beginning of the hour and turn it into an a plus bi type of complex number. In other words, what we have to do is the division. So the division is going to be, I multiply now I'm going to ask you to do it in your head. Well, I multiply the top and bottom by -1 minus I. What does that put in the denominator? 1 squared plus 1 squared, 2. And in the numerator, -1 minus I. This is the same as that. But now it looks in the form a plus bi. It's -1 over 2 minus I times 1/2. So this is multiplied by e to the x and cosine x. So if you're doing it and practice a little bit, please don't put in all these steps. Go from here, well, I would go from here to here by myself. Maybe you shouldn't. Practice a little before you do that. And now what do we do with this? Now this is in a form to pick out the real part. We want the real part of this. So you don't have to write the whole thing out as a complex. In other words, you don't have to do all the multiplications. You only have to find the real part of it, which is what? Well, the e to the negative x will be simply a factor. That's a real factor, which I don't have to worry about. And in that category, I can include the 2 also. So I only have to pick out the real part of this times that. And what's that? It's negative cosine x. And the other real part comes from the product of these two things. I times negative I is 1. And what's left is sine x. So that's the answer to the question. That's the integral of e to the negative x cosine x. Notice that it's a completely straightforward process. It doesn't involve any tricks. Unless you call going to the complex domain a trick, but I don't. It's just something that as soon as you see in this course the combination of e to ax times cosine bx or sine bx, you should immediately think, and you're going to get plenty of it in the couple of weeks after the exam, you're going to get plenty of it, and you should immediately think of passing to the complex domain. That will be the standard way we solve such problems. So you're going to get lots of practice doing this, but this was the first time.